Okay. Uh, Before Diwali vacation, we have completed interactions, use cases, and use case diagrams from UML, Unified Modeling Language. So now we move towards next diagrams, interaction diagrams, and activity diagrams. So in interaction diagrams, we will study the concept of modeling modeling flow of control by time ordering and modeling flow of control by organization, then forward and reverse engineering. So activity diagrams, state chart diagrams, and use case diagrams are three other kinds of diagrams used in UML for modeling and dynamic aspects of system. Activity diagrams, sequence diagrams, and collaboration diagrams. So out of them, sequence diagrams and collaboration diagrams, both of which are called as interaction diagram. Interaction diagram is a combination of sequence diagram and collaboration diagrams. So these two diagrams out of five diagrams used for UML as a dynamic aspects of system. So interaction diagram shows interaction consisting of set of objects and their relationships including messages that may be dispatched among them, and sequence diagram is an interaction diagram that emphasizes on time ordering of messages. A collaboration diagram is an interaction diagram that emphasizes on structural organization of the objects that send and receive the message. So there is a difference is sequence diagram and or collaboration diagram. In sequence diagram, there is the sequence diagram is also known as interaction diagram on the time ordering message, whereas the collaboration diagram is known as interaction diagram on the structural organization of the objects that sends the message and receives the messages. So you use the interaction diagram for dynamic aspects. For the most part, this involves modeling concrete or prototypical instances of classes, interfaces, and the components and nodes along which messages are dispatched among them. In all in the context of scenario that illustrates a behavior. So interaction diagrams may stand alone to visualize, specify, construct, and document to model one particular flow of control of only important for modeling the dynamic aspects of system, but also for the constructing executable systems through forward and reverse engineering. So interaction diagrams, see in this figure, there are two types of diagrams, sequence diagram and collaboration diagram. First figure, this figure is interaction diagram. Interaction diagram form interaction diagram, and second figure is a collaboration diagram. See, the both structure is different, but sending message or working of both figures are same. First is time dependent and second is structural dependent. So figure 1, this first figure shows to build up this storyboard of two ways, emphasizing a time ordering message and emphasizing structural relationship. This is first figure is depends on time ordering and second is structural relationships. So both diagrams are semantically equivalent. They can convert one to other without any loss of information. So in the interaction diagram shows a set of objects, relationships, including messages. So this first is sequence diagram, and sequence diagram is interaction diagram that depends on time ordering messages. Graphically, a sequence diagram is a table that shows objects arranged along x-axis. These are the objects, client, transaction. This is the one example. You can take any other example. Okay, the classic client, transaction, ODBC proxy. These are the objects placed along x-axis, whereas the time ordering placed along y-axis. This is okay. Then in collaboration diagram, there is in that is interaction diagram based on the structural organization of the object. The same figure sequence diagram can be drawn in collaboration diagram such a way in that objects are based in the form of structures that sends and receives the message in the form of time depend, or there is a particular sequence. See here in structural diagram, you have seen first create message, okay, then set actions AD0, then from transaction to ODBC proxy, you have sent the message set value D3.0. Okay, then from transaction also send message set value ACO. Then from transaction you have sent committed, and from client to transaction to send destroy the connection. So from client to transaction, there are total three messages sent. First message sent is a create. Second message send set actions AD0, and third message destroy. So set, see in collaboration diagram, first message send create, second message send set actions AD0, and third message send destroy. Okay, whenever you have sent from client to transaction, second message is sent from client to transaction, set actions AD0, then from at the same time duration, you have sent from transaction to proxy, ODBC proxy, two messages sent. Set value D3.4 and set value AC0. These are 2.1 and 2.2. These two messages from transaction to ODBC proxy. Then there is no any message from ODBC proxy to transaction. See in sequence diagram also in collaboration diagram. Then third message send one message sent from transaction to client is committed. This is one message sent, that is local here, and then you send a destroy message from client to transaction, then this is third message destroy. So collaboration diagram is interaction diagram that based on the structural organization of objects that send and receive objects. Graphically, collaboration diagram is a collection of vertices and arcs, whereas the sequence diagram depends on the graphical representation in the form of x-axis and y-axis. Next, what are the common properties in a sequence diagram and collaboration diagram? So interaction diagram is just a special kind of diagram that shares same common properties over all other diagrams, that is the name, graphical content, and projections into the model. So what is a distinguish interaction diagram from all other kinds of the diagrams in its particular format, that is objects, links, and messages. These are the common properties. So there is some difference from interaction diagram to other diagrams. So interaction diagram is basically projection of elements found in interaction And the semantics of interaction context, objects, roles, links, messages, and sequencing apply to the interaction diagrams. So we'll see one by one sequence diagram and collaboration diagram. So see in figure sequence diagram, there are three objects: client, transaction, and ODBC proxy. So first placing the object that a particular that object participate in the interaction at the top of the diagram along x-axis. These objects are along x-axis: client, transaction, and ODBC proxy. Whereas you place the objects initiates interaction at the left. So initial object at the left start to communicate. So increasingly more subordinate objects to the right. This is the most important object towards left side, whereas the subordinates object towards its right. So you place the messages those objects send and receive along x-axis, along y-axis. Sending message time duration starts from this point to and ends on these points. So you send message along y-axis, whereas you have kept the object along x-axis, and this gives the reader a clear visual cue for the flow of control of where over the time. So sequence diagram have two types of features. First, you can specify the val- validity of objects or link by marking with its new destroyed or transient content representing changing value, state, or roles of an object. Whatever the object state, what are the roles, changing values, what is newly created objects, what is destroyed objects, you can specify that important objects are linked by marking new or by given some specific name, its state, its changing value regarding to that object. So the first objective or first feature of the sequence diagram, so there is object lifeline. See in this figure, this is the object client's lifeline from this point to this point, where are transitions lifeline from this point to this point, where in ODBC proxy there are two objects. First objects have lifeline this point to this point, and second objects this proxy this point to this point. So the most objects that appear in interaction diagram will be existence for the duration of interaction. So these objects are all aligned on the top of the diagram of, with their lifelines drawn from the top of the diagram towards the bottom. So objects may be created during the interaction. Their lifelines start with respect to their messages stereotyped as create. So objects may be destroyed during interaction. Their lifelines end with the receipt of the message stereotype destroy. See in this figure, whenever you have given the message destroy, their lifeline ends. Hello. So when you so there is a node If an object changes the value, its attribute, state, or its role, you can place the copy of object icon, its lifeline at the point changes occur during these or those modifications. And second feature is there is a focus of control. Focus of control is a tall, thin rectangle that shows the communication link between objects. Focus of control shows the during time slot during which through a subordinate procedure. See here, this time duration shows the communication link or communication time slot for one object to another object. This is time slot for communication time slot from one object to another object. So in second collaboration diagram is based on the organization of objects and that participate interactions. See this figure. Figure shows the collaboration diagram. First placing objects participate. You can draw mirror image like this. You can take this object this side or this side. Depends on user's choice. So this client, ODBC proxy, transaction, these objects placed at proper place as a vertices. So you render the links and content connect these objects as arcs. Connect these objects arcs or links for communicating with each other. So finally you adorn these links the messages that objects send and receive. When you send or receive the message from one object to another object, so there is a particular sequence. First you send create a link from client to transaction. Second, message send actions AD0 from client to transaction. So there are two action paths or sub paths from transaction, same action set actions. So you should have two set values. First set value that is 2.1 from transaction to ODBC proxy, that is set value D 3.4 and set value D A C0. Then you are saying the message third message destroy from client to transaction. So finally you adorn these links with the messages that objects send and receive. This gives a reader a clear visual cue, the flow of control, the context of the structural organization of the objects that collaborate. So collaboration diagram have two features from distinguish from the sequence diagram. First feature, there is a path to indicate how one object is linked with another object. See, there is a path how one object is linked with another object with particular order. So you can attach the path stereotype that is far end links such as local D indicating the designated object is local to the sender. So typically you will only need to render the path of link explicitly for local parameter, global and self, but not association paths. So second feature is there is a sequence number to indicate time order of message. You prefix the message with a particular number starting number 1. So increasing monotonically for each new message in the flow of control, that is 2, 3 and so on. So for nesting of particular message you can use a decimal numbers. Suppose for message first there are two messages, you can use for first message 1.1, one for second message of first message you can use 1.2 in the nested form of message 1 and so on. So note that along the same link you can show many messages and each of will have unique sequence number for both iteration and branching. UML does not prescribe the format of the expressions inside the bracket. You can use pseudocode for the syntax of specific programming language. So what are the common uses? You can use interaction diagram to model dynamic aspects of the system. These dynamic aspects may involve interactions of any kind of instances in any view of systems architecture. Active classes. So when you use an interaction diagram to model some dynamic aspects of system, you can do in the context of system of whole or subsystem operation of class. You can attach interaction diagrams to use cases and collaboration diagrams. So when you when you model dynamic aspects of system, you typically use the interaction diagrams into two ways. First, to model flow of control by time ordering, to model flow of control by organization. So here, first, to model flow of control by time ordering, here you will use sequence diagrams. Modeling flow of control by time ordering emphasis on passing messages as they unfold over time, which is a particularly useful way to visualize dynamic behavior in the context of use case scenario. Sequence diagram is do a better job of visualizing simple interaction and branching than to the collaboration diagram. Second, to model flow of control by organization, here you will use collaboration diagram. So modeling flow of control by organization emphasizes structural relationship among the instances, interactions, and messages to be passed. The collaboration diagrams do better job visualizing complex interactions and branching and visualizing multiple concurrent flow of control than do sequence diagrams. What are the common modeling techniques? So consider the object that live in the context, subsystem, operation or class. Consider also the objects and roles that participate in use case or collaboration. To model a flow of control that winds through these objects roles, you use the interaction diagrams to emphasize the passing messages as they unfold there over time. You use a sequence diagram, a kind of interaction. So what is the note for sequence diagram? Sequence diagram, you may want to model the changing state, role, attribute or values of the object. There are two ways for this. First, object may appear multiple times in diagrams, each showing different states, roles, or attribute values. Then you use transition stereotyped as become to indicate its change. And second, for changing state, you can place state icon directly on object's lifeline. Interaction diagrams can begin or end at any point of the sequence. A complete trace of flow of control would be incredibly complex, so it's reasonable to break up parts of larger flow of control separate diagrams. So Modeling flow by control of organizations. So consider objects that live contains systems, subsystems, operations of class with their different roles participates in a use case or collaboration. So model flow of control that winds through these objects roles, or you can use interaction diagrams to show passing messages in the context in the form of structure. You use the collaboration diagram in the form of interaction diagram. So to model set context of interaction, whether it is a system, subsystem, operation or class, one scenario you use the collaboration. So set the stage set the stage for interaction by identifying which object play a role in the interaction. So lay them out in the form of collaboration diagram as a vertices in a graph, placing more important objects at the center of the diagram and their neighboring object to the outside. So set initial properties of object. These objects are important values, state or role of the object changes it significant ways over the duration of the interaction. Place the duplicate objects of the diagram, update it with these new values, and then connect them by a message stereotyped as become or a copy with suitable sequence number. So there are two objects. First, lay out the association links first. Then most important one is because they represent structural connection. And second, they lay out the other links next, adorn them with suitable stereotypes such as local or global to explicitly specify how these objects related with one another. So starting with messages that initiate the interaction, attach each subsequent message to the appropriate link, setting its sequence number as appropriate. Show nesting by usual decimal numbering. If you need to specify time or space constraint, adorn each message with timing mark and attach suitable time or space constraint. If you need to specify this flow of control more formally, attach pre or post conditions to each message. So what is forward and reverse in collaboration diagrams, especially in the context of diagram as an operation? So reverse engineering also most possible for most important possible for both sequence and collaboration diagrams, especially in the context of code. And sequence diagram is possible most important in the form of operation whereas collaboration diagram in reverse engineering, sequence diagram and collaboration diagrams are important in the form of code, that is body of an operation. So forward engineering is straightforward. Reverse engineering is hard to easy to get much information from simple reverse engineering. So it is hard part is being clever about the details and keep. So, however, more interesting that reverse engineering of a model from code is animation model against its execution of deployed system. So what are the hints and tips regarding the interaction diagrams in UML? So sequence diagram and collaboration diagrams are both projections on the same model of systems dynamic aspects. So no single interaction diagram can capture everything about systems dynamic aspects. Rather than you will want to use many interaction diagrams to model the dynamics of the system as a whole, as well as the subsystems, operations, classes, use cases, and collaborations. So a well-structured diagram is focused on communicating from one object to another object in the form of systems dynamic structure. So a well-structured interaction diagram contains only those elements that are essential to understanding data aspects. A well-structured interaction diagram provides details consistent with its level of abstraction and should expose only those adornments that are essential to understand. A well-structured interaction diagram is not a minimalist that misinforms to the readers about semantics and that are important. So when you draw interaction diagram, give it a name that communicate its purpose. Use a sequence diagram if you want to emphasize to the time ordering of message. Use a collaboration diagram if you want to emphasize to organization of the object involved in the interaction. So lay out these elements to minimize lines that cross. Use notes and colors as visual cues to draw attention to the important features of your diagram. Use branching sparingly. You can represent complex branching much better using activity diagrams. So next is activity diagram. Next is activity diagram. So in this chapter we will study modeling a workflow, modeling an operation, forward and reverse engineering. So activity diagrams is most important diagrams out of five diagrams. Activity diagram is depends on a flow chart. It looks like a flow chart showing flow control from one activity to other activity. We You can use activity diagram to model dynamic aspects of system. So for the most part, these involves modeling the sequence, steps, computational process. So with this activity diagram, you can also model the flow of object from it moves from one state to another state or with different points in the flow of control. So activity diagrams stand alone to visualize, specify, construct documents the dynamics of the society of objects, and they may be used to model flow of control of an operation, whereas interaction diagrams emphasize flow of control of from object to object, whereas activity diagram flow of control from activity to activity. This is the difference between interaction diagram and activity diagram. So activity is ongoing non-atomic execution within a state machine. Activities ultimately result in some action which is made up of executable atomic computations that result in a change in a state of system or return of the value. Activity diagrams are not only important for modeling the dynamic aspects of system but also the for constructing executable systems through forward and reverse engineering. So activity diagram is most important a flow chart that emphasizes on activity that take place from over time. See the figure carefully first. हॅलो, मे आय ऑडिबल? आवाज येतोय? Okay. So activity diagram is most important look like a flow chart. It is based on activity that takes place over time. See, see this figure. It looks like a flow charts. In flow chart, there are two steps that are important: start and stop. That is initial state and final state. So start state or initial state shown by the solid circle, whereas the final state can be shown as a solid circle enclosed by simple circle. So and remaining these rounded rectangles are the action states. This is rhombus shows as a branching state, whereas uh, it can be shown as a condition. It have two parts, true or false. That is, this using this condition you can fork that the state, and there are two ways, either true state or false state, and then combine the result, that is join, concurrent join, so that we can get a particular result. So activity diagram is an interaction diagram turned inside out. An interaction diagram add the objects that message passes. An activity diagram looks the operation that are passed among the objects. The semantic difference is subtle but result in a very different way of looking at the world. So activity diagram shows flow from activity to activity. It is ongoing non-atomic execution within a state machine. Activities ultimately result in some action which is made up of executable atomic compensations that result in a change in state of the system or return of value. Actions encompass calling other operation, sending a signal, creating or destroying an object, or some pure computations such as evaluating an expression. Graphically, an activity diagram is collection of vertices and arcs. What are the common properties? Common properties, just like a special kind of diagram that shares common properties, so that other diagrams same as other diagrams such as name and graphical contents. So what are the contents such as activity states and action states, transitions, objects? So activity diagram is based on a projection of elements found in activity graphs, which is a special case of state machine in which all or most states are activity states, and in which all other most transitions are triggered by completion of activities in the source state. Because an activity diagram is kind of state machine, all the characteristics of state machines apply. That is, the activity diagram can contain simple and composite state branches, forks, and joins. So link all other diagrams. Activity diagrams may contain nodes and constraints. So action states and activity states. So in the flow of control modeled by activity diagram, things happen. So you might evaluate some expression that says all the values of the attribute and that returns some values. Alternatively, you might call an operation of an object, send a signal to object, or even create or destroy the object. So these executable atomic computations are called as action states because they are states of the system, each representing the execution of the action. So what is the action states and activity states? So see this figure. These are the examples. This figure is known as the s- state or action, and what is the simple action can be written in between this rounded rectangle. This is the action states. These both are action states. This is simple action and this is in the form of expression. So UML does not prescribe the language of these expressions. Abstractly, you might just use structured text, or more concurrently, you might the syntax and semantics of specific programming language. So action states cannot be decomposed. Furthermore, action states are atomic, meaning that events may occur, but the work of action state is not interrupted. Finally, the work of action state is generally considered to take insignificant execution time. So in the real world, of course, every computation takes some amount of time and space. Especially for hard real-time systems, it's important that you model these properties. In contrast, activity states can further be decomposed, their activity being represented by other activity diagrams. So furthermore, activity states are not atomic, meaning that they may be interrupted, and in general they are considered to take some duration to complete. You can think of action states special case of an activity state. An action state is an activity state that cannot be further decomposed. Similarly, you can think of the activity state as a composite whose flow of control is made of other activity states and action states. So zoom it in details activity state, you will find other activity diagram. So figure shows there is no notational distinction. See the figure carefully. So this figure shows no notational difference between action and activity state. This is the action entry set lock. This is the action and activity state, that is do construction. This is the activity and this is the action entry or set lock. See in this figure. So and these are the sub machines. So action state and activity state are just special kinds of states in the state machine. When you enter action or activity state, you simply perform action or activity. When you finish, control passes to the next action or activity. So activity states are somewhat of shorthand. Therefore, an activity state is semantically equivalent to expanding its activity graph in place until you only see the actions. So nonetheless, activity states are important because they help to break up complex computations parts in same manner as you use operations in the group and reuse expressions. See the figures carefully. So in transition, there are different actions. See this figure. There is start state shown by solid circle and stop state shown by the solid circle covered by simple circle. So these are the action states: selection site, commission architect. These are the examples. So these are the action states, and this arrow is known as triggerless transitions. In flowchart, we can call this the directions. So you can specify this flow by using transitions to show the path from one action to other action or next action. So you in UML you represent transition as simple directed line. So semantically this is called as triggerless or completion transitions because control passes immediately from one place to another place. So see in this figure, next or without delay, control flows from transition and passes to the next action or activity. You execute that state entry action if any. Then you perform action or activity that target state again following next transition. This flow of control continues indefinitely or until you encounter स्टॉप स्टेट. जोपर्यंत तुमचं स्टॉप स्टेट येत नाही तोपर्यंत एका स्टेट पासून दुसऱ्या स्टेट पर्यंत किंवा एका ऍक्टिव्हिटी पासून दुसऱ्या ऍक्टिव्हिटी पर्यंत कंट्रोल फ्लो राहतो. सो indeed a flow of control has a start and some end place. Whenever you can start any flow chart, there is start state and stop step. Similarly, for this activity diagram, there is a start step, also stop step, that is stop state. So therefore, as figure shows, you may specify initial state with solid ball and stop state solid ball inside circle. So there is a branching, that is in flowchart we can say conditional. So conditional, it is shown by the rhombus. Similarly here branching is shown by the rhombus. So conditional have two parts, true or false. In case of flowchart, similarly, it also have two parts. So due to this branching, there is four condition appears. Okay, and they solve differently. So simple and sequential transition are common, but they are not aren't only the kinds of path you will need to model a flow of control. As a flowchart, you include a branch which specifies alternate paths that taken based on Boolean expressions which have answers true or false. So this figure represents a branch as a diamond or rhombus. A branch may have one incoming transition or two or more outgoing lines. One incoming line, one incoming transition or incoming line, and outgoing two, minimum two, or max more than two. So across all these outgoing transition guard, you should not overlap, otherwise flow of control would be ambiguous, but they should cover all possibilities, otherwise flow of control would be freeze. So next condition, forking and joining. So simple and branching sequential transitions are most common paths you will find in activity diagrams. However, especially when you are modeling workflows of business process, you might encounter flows that are concurrent. In UML, you use a synchronization bar. This is a synchronization bar to specify forking and joining. To specify forking, this is synchronization bar. In this example, prepare speech, there is fork. First is glacier and second part is decomposer. And for joining glacier and decomposer, there is again bar for joining. So that we can go next step. So synchronization bar is rendered as a thick or thick horizontal or vertical line. Thick horizontal or vertical line. So joins and force should be balanced, meaning that the number of flows of users should be equal to the number of flows of joins. Signals in the submachines associated with each communicating activity state. So then swim lanes you will find the useful especially when you are modeling workflows of business process to partitions the activity states of an activity diagram into groups and each group representing business organizations responsible for those activities. So in UML, each group is called as swim lane. Each group, this is first group, second group, third group. This group, in this example, customer, sales, and warehouse. These are group names is known as swim lanes. And each group representing business organizations. So customer is responsible business organization. Similarly, sales is responsible business organization. Warehouse is responsible for business organization. So each group is called as swim lane because visually each group is divided from its neighbor by a vertical solid line. This customer is divided from other groups vertical solid line. This similarly sale is divided by these two vertical solid lines from customer to warehouse. So each swimlane has name unique within the diagram. So swimlane really has no deep semantics.
except that it may represent some real world entity. So each swim lane represents high level responsibility for the part of overall activity of an activity diagram, and each swim lane may eventually be implemented by one or more class in an activity diagram partitioned into swim lanes. Every activity belongs to exactly one swim lane, but transitions may cross lanes. So one swim lane depends to other swim lanes. See in this customer request for products, there is a for conditions. So divided into two parts. First part as it is in customer swim lane, and second part goes to the sales swim lane, that is processed order. Then further goes to the warehouse for pull materials, then ship order, then joins with this request product, then again in it falls, that is receive order and bill customer, then again joins, then pay bill, then close order and then stop. So objects may be involved in the one flow of control associated with an activity diagram. For example, in the workflow processing order, as in the previous figure of vocabulary, your problem space will include such as order and bill. See in this figure, order and bill. Instances of these two classes would be processed by certain activities, and other activities may modify objects. So in addition to showing the flow of objects through an activity diagram, you can also show how role, state and attribute values change. As shown in the figure, you represent state of an object, naming its state in brackets b- below the object's name. Similarly, you can represent the value of objects attributes by rendering them in compartment below the object's name. So what are the common uses? Activity diagram to model the dynamic aspects of system. So diagrams represents may involve activities of any kind of abstraction in any view of systems architecture, including classes, active classes, interfaces, components and nodes. So when you use activity diagrams to model some dynamic aspects of system, you can do so in the context of virtually any modeling element. Typically, however, you will use activity diagrams in the context of system as a whole, a subsystem in operation or a class. You can also attach activity diagrams to use cases and collaborations to model the dynamics aspects of society of the objects. So dynamic aspects in case of activity diagrams into two ways: first to model the workflow and second the model the operation. To model the workflow, here we will focus the activities as viewed by the actors that collaborate with the system. Workflow often lie in the fringe of the software intensive system and are used to visualize, specify, construct and document business process that involve system you are developing. Whereas in model operations, here you will use activity diagrams as flowcharts to model details of computations. In this case, you use activity diagrams for modeling branch, fork, and join states, particularly important. So, in the context of the activity diagram used in the way to involve the parameters of the operation and its local objects. So, no common modeling techniques. So no software intensive system exists in isolations. There's always some context in which system lives, and that context always encompasses actors that interact with the system, especially for the mission critical enterprise softwares. You will be automated systems working in the context of high level business processes, and these business processes are kinds of workflows because they represent the flow of work of objects through the business. So you can model these business processes for the way these various automated and human systems collaborates by using activity diagrams. So modeling and operation activity diagram can be attached to any modeling elements for the purpose of visualizing, specifying, constructing and documenting elements behavior. So you can attach activity diagrams to classes, interfaces, components, nodes, use cases and collaborations. The most common elements in which you will attach an activity diagrams is an operation used in manner. Activity diagram is simply flowchart of operations. An activity diagram is primarily advantage of an elements in the diagram semantically tied to reach model. For example, the other operations or signals that action state references can be typed or checked against the classes of the target objects. So to model an operation, the collect abstractions that involve in this operation. This includes operation parameters, attributes enclosing classes, certain neighboring classes, identify preconditions or post-conditions, operations, initial state of the operations, the final state. Also identify the invariants of enclosing classes most hold during the execution of the operation. So beginning at the operations, initial state specify the activities, actions that takes place over time, render them in the activity diagram either activity states or action states. So use branching as necessary to specify conditional paths and interactions. Only if these operations is owned by the active class, use forking and joining as necessary to specify parallel flows of control. So forward engineering and reverse engineering. In forward engineering is possible for activity diagram, especially context of diagram is an operation. So there is a bit cleverness here involving declaration of two local variables, a less, okay, and reverse engineering is also possible for activity diagram, especially in the context of code of the body of the operation. So more interesting that reverse engineering of model code in the animation of model against the execution of deployed system. So what are the hints and what are the tips in case of activity diagrams? When you create activity diagram in UML, remember that activity diagrams are just projections on the same model of system's dynamic aspects. No single activity diagram can capture everything about systems dynamics aspects. Rather than you want to use many activity diagrams to model the dynamics of the workflow of an operation. So a well-structured activity diagram is focused on communicating one aspect of systems dynamics. A well-structured activity diagram contains only those elements that are essential to understand the aspects. A well-structured activity diagrams provides detailed, consistent what its level of abstraction. You expose only those adornments that are essential to understanding. A well-structured activity diagram is not the minimalist that misinform the readers about the important semantics. So when you draw activity diagram, give it a name that communicate its purpose. When you draw an activity diagram, start with modeling primary flow. When you draw an activity diagram, address branching, concurrency and flow of control or object flow as a secondary consideration, possibly in separate diagrams. When you draw an activity diagram, lay out its elements to minimize lines that cross. When you draw an activity diagram, use nodes, colors as visual cues to draw attention to important features of your diagrams. Okay, we have completed activity diagram. Next is events and signals. We will complete in next lecture. We stop here.